Welcome to today's Explainer. We're unpacking the future of all-electric heating and cooling, pulling directly from a really fascinating breakdown by MEP Academy. Heat pumps are literally everywhere right now, but at the commercial scale, the industry is going through a massive, ground-up transformation. Today, we're looking at the heavy hitters of building climate control and how a totally new generation of technology is completely rewriting the rulebook. Let's jump right in with a question that kind of turns traditional commercial HVAC on its head. If you've spent any time around building mechanics, you know the golden rule, right? Chillers cool things down and boilers heat things up. Two completely different machines doing two completely different jobs. But what if they weren't? Can a chiller actually be a boiler? Believe it or not, the answer is a massive yes. And this is a real game changer because it completely revolutionizes building design by ditching fossil fuels entirely. We are talking about the modular air-to-water heat pump chiller. This isn't just some minor incremental upgrade. It's a fundamental shift in how we manage the climate inside massive structures, all while staying 100% electric. So here's our roadmap for today. We're going to cover the all-electric future, modular scalability, system redundancy, the dual chiller-boiler combo, mastering part load efficiency, and finally, decarbonization and next-gen sustainability. Let's get to it.
Section 1. The all-electric HVAC future, demystifying the next generation of climate control.
So, traditionally, big commercial buildings needed a massive gas-guzzling boiler for the winter and a completely separate chiller for the summer. It's just how it was always done. But a modular air-to-water heat pump chiller, it replaces those legacy machines entirely. It functions as both your heating and cooling source, without burning a single drop of gas. Basically, by linking up multiple compact all-electric units, it hits the exact load your building demands. It's pretty incredible.
Moving on to Section 2. Scalability, the modular advantage. We're talking about the building blocks of commercial HVAC. Seriously, just think about the sheer logistics of replacing a traditional commercial chiller. You usually have to block off entire city streets, bring in this massive crane, and hoist it onto a roof. It's a total nightmare, right? But with this modular approach, you get to skip all of that. Instead of expensive cranes, you literally just offload these compact units from a flatbed truck using a standard forklift. You can roll them right through a regular doorway or push them into a standard freight elevator. And once you get them to where they need to go, maybe a cramped urban rooftop or a tight basement, you just assemble the modules together. It is incredibly slick for new construction and an absolute lifesaver for retrofits where space is practically non-existent.
And that translates directly into massive scalability. Whether you need just 30 tons to start or you're scaling all the way up to York's massive 4,480-ton capacity with 32 modules, you only install what you actually need today. Take a manufacturer like Trainik, for example. Their ThermaPit line lets you start at 30 tons and expand to 360 tons by linking up to 12 modules. LG lets you scale up to 300 tons with 5 modules. Phased installation is actually a reality now. If you know your building's footprint is going to grow in a few years, you don't have to waste money on a grossly oversized system right now. You just plug in another module later down the line. Section 3. Reliability through system redundancy. Why failure is simply not an option.
Put yourself in the shoes of someone running a hospital, a school, or maybe a high-stakes research lab. In those places, a total HVAC failure isn't just uncomfortable, it is a full-blown catastrophe. Maintaining that stable indoor climate is absolutely essential for safety, productivity, and staying on the right side of strict regulations. Well, because these systems require a minimum of 2 modules, like Trane's AXM baseline configuration, for instance, you get this built-in, fail-proof redundancy. If one unit goes down, you don't lose the whole building. The inherent backup instantly kicks in. Plus, each module has independent controls, so a facility manager can isolate and fix one unit while the others keep humming along. Throw in independent defrost cycles and easy change filters, and you've got serious peace of mind against equipment failure.
Section 4. The chiller-boiler combo. Dual function heating and cooling.
Okay, here is where the operational magic really happens. These units don't just cool with a simple reversing valve like a basic home heat pump. No, they can switch modes entirely within a single machine on a massive commercial scale. Think about it. A standard 2-pipe system forces the whole building to be either hot or cold. But a 4-pipe or multi-pipe system, absolute game changer. Imagine a massive hotel in the dead of winter. The interior core is packed with people and equipment, so it actually needs cooling. Meanwhile, the perimeter by the windows is freezing and desperately needs heat. This modular chiller can provide simultaneous heating and cooling at the exact same time. And again, all electric, zero gas required. Section 5. Mastering part load efficiency, ending the waste of oversized chillers. Historically, buildings relied on these single, massive, oversized chillers. Even if a building was only, say, 20% occupied on a weekend, that giant machine still had to fire up just to meet that tiny load. Talk about a massive waste of energy. But today, the tech has finally caught up. Thanks to inverter-driven compressors and variable-speed fans, each individual module dynamically adjusts its output based on what the building actually needs right then and there. A module can scale its active output anywhere from 15 to 100% capacity. That big chunk of saved energy, that goes straight back to the bottom line. Whether occupancy fluctuates or the seasons change, the system matches the load exactly. Nothing more, nothing less. As the folks at MEP Academy highlight, this staging operation perfectly optimizes energy use. Their breakdown notes that a system with several modules can stage operation, running fewer units at higher efficiency or distributing load across multiple units at lower capacities. Because you've got multiple modules communicating with each other, the system's brain constantly figures out the absolute most efficient way to run. It might choose to run just a couple of units at peak efficiency, or it might spread a light load across all units running at super low, highly efficient capacities. The result? Perfect comfort with zero historical energy waste. Section 6. Decarbonization and next-gen sustainability. Actively achieving net zero building design. Pulling back to look at the big global picture, these systems are actively driving the real estate and construction industries towards some very strict modern decarbonization goals. And the potential impact is genuinely staggering. We're talking about a 75% reduction in global warming potential when these systems use next-generation refrigerants. By ditching the older R410A refrigerants and embracing new formulas like R454B in a totally electric system, you're making a massive, highly quantifiable leap toward genuine net zero building design. So, just to tie all this sustainability impact together, these systems are 100% electric, which completely breaks our reliance on natural gas for heavy commercial heating. And that is exactly what helps building owners comply with those strict new global energy codes rolling out everywhere. They leverage the next generation R454B refrigerants we just talked about, and crucially, they are cold climate ready, meaning they can pull heat out of freezing winter air for year-round operation. Basically, they package flexibility, efficiency, and sustainability into one brilliant design. It's really the undeniably smart choice for the future of HVAC. And that brings us to a final thought for you to chew on as you look toward designing and managing the resilient net zero buildings of tomorrow. As energy codes tighten up across the globe, can your next commercial building project afford not to use a modular heat pump chiller? When you add up the ease of installation, the scalable costs, the absolute built-in redundancy, and those massive environmental benefits, well, the days of the giant gas-guzzling boiler and separate chiller are definitely numbered. Thanks so much for joining me for this explainer, and I hope it gave you a really clear, structured look into the very near future of all-electric climate control.